very similar to derivatives, right? And we already discussed this. Right? So what's the antiderivative? Or what's the derivative here? 2x. Okay. Good. So what is the antiderivative of 2x? Oh, you're so close. Very close.
What if the original problem was like x squared minus 1? And the derivative of that is 2x.
Okay. Let's try. What was it?
Well, if you have an equation that's like x squared minus 1, the derivative of that's still 2x.
Okay.
So where do you find that?
Okay. He has already identified the one little twist with antiderivatives. How do we get the minus 1?
You don't just gotta say this.
Right? Okay, so when you calculate the antiderivative, at this point, I'll show you how to find that answer. It's pre-calculus, simple. At this point, the antiderivative of 2x is x squared plus a constant. Because we don't know if that constant is 0 or -1 or 5 million. Right?
So that's how you answer it.
For now, the next 2 days, you will put a plus C on every antiderivative that you calculate.
Okay.
Because we don't know if there is a number in the original function, right? We just don't know. Okay. So let's
Imagine that derivative is like if it's giving you the derivative out your quotient, that's probably like all the data is there.
you'll be given that what you need to calculate the value C. But again, that's probably going to be next Tuesday. So there you go. Okay, we write. So antiderivative, this is kind of a non-mathematical way to say it. This is the verbal, right? The way we write, so we have derivative. Okay. We would write integral. Oops, that's wrong. Get way ahead of myself.
So we get to do this.
Yeah, and that's kind of sloppy. If you want to be perfect, which I know some of you really try, but are never going to try it, that's pretty darn close. So this means calculate the antiderivative of 2x. Okay, so you can say this lots of ways, but calculate the antiderivative of 2x in this case. Okay, right? You could also say the integral, this is a word we will get very familiar with, of 2x is, right, so there's two ways to say that. We will get into the zone of saying it like this. Okay. We will start using that word more and more, the integral. But I will say, calculate the antiderivative sometimes. Right? So that's the basic framework of what we're looking at. The third quarter is using that to do a lot of math.
Great.
Okay? With the geometry concept. So, you okay with that?
Yep.
All right. Let's formalize the integral, the power rule. Okay, so is the antiderivative of x squared?
2x plus c.
No, that's the derivative. Derivative of x squared is 2x. See,
It's
you
x
have to
squared.
make sure that you keep those two separate.
Wait,
It's
what?
x
Like
squared.
they're related, but you gotta keep them separate, right? It's x what?
Squared plus c.
No.
What?
You should just.
What derivative would give you x squared? X cubed. You're close.
That would give you 3x.
3x
Right.
squared.
That'd be 3x squared.
Okay, that would give you 3x squared. So how would we counteract that 3? Because there's no 3.
X cubed
Minus
over
3x.
Nope.
Plus c.
How would we? Okay, so the derivative of that is 3x squared.
Yeah.
How do we get rid of a 3 that's multiplied?
Divided by
Divide.
3.
Here's what it is.
Wait,
I don't like it.
why is it just x cubed?
Yeah, why?
Because-
Why
can't
isn't
it
that
be
3x squared?
Because you divided by
The antiderivative?
Because that's
What is the derivative? Okay, what's the derivative
Some nerdball
of x cubed over
sitting in a
3?
small room is like, I'm gonna come up with this. So who even teach it?
Accurate.
The derivative of this? 3x squared over 3.
So then that gives you x squared.
Wow.
Those match.
That's crazy, though.
It's not crazy. It's derivative and it's the relationship. It has to hold.
It's not.
Is this going to be a retest?
Probably.
Okay?
Yeah.
This is why.
This is why what?
He doesn't come to school.
This is not mind-blowing.
It is.
It is like walking forward and walking backwards.
That's
You
why.
This is the equivalent of Jesus walking around.
You don't even have to do the moonwalk to go backwards. It's a division problem. Okay, so again, consider. Let's try another one.
Oh, goodness.
This is like me trying to say stronger across the free one.
It's hard to know.
X to
Just draw an
the
x.
Divided by 5. Oh, okay.
I thought you just said.
So you just add
4
one?
divided by 5.
Oh.
add 1 to what?
The exponent
Okay, and
divided by that new one.
there you go. That's the
Illuminati confirmed.
thanks, Jay-Z.
So then would it be?
So add 1 to the exponent.
N plus 1 over
Over.
N plus 1.
Plus
Plus
c.
C. Wow.
That's it.
Oh, wow.
Because a derivative, you subtract 1. Okay, you bring it down and you subtract 1 here. Okay, so on a derivative, you multiply it and subtract from the exponent.
I
An
know.
antiderivative, you add and divide. See the relationship, right?
Yes.
If that is the integral power rule, for lack of a better term.
Oh, that's not too bad.
No, it's not.
Does it get worse than
Because you can
this?
add and you can divide.
Does it get worse than this?
Okay?
Wait a minute.
Yes, really, it would get much worse.
Okay.
Oh, no, why did you bring it?
What's the question? What did you ask?
Since he asked, I just blame this on Kelly.
I don't know what it is. She's named the school. I'm gonna learn a tiny slim chance.
Okay, good job, good job.
Cosine, obviously, is it negative?
That's it.
What's the derivative of cosine? Negative sign. We don't have a negative here, correct? So you have to put it there.
Oh.
You have to work with that. Because the derivative of,
Cosine is negative sine, and we multiply it by a negative, which makes it a positive.
you can't just, the negative can't just disappear, right? So you have to carry it through.
That was so much easier.
I just
than
forget to write it.
All those relationships hold.
Wait, if it's X squared
It's
minus one.
It's locked. Where was your
It wasn't up today.
He's still in the dryer.
It's a -1.
No, he's on the dryer anymore. He's probably sitting on top of the dryer. My mom was like, really?
All right, here's a, okay, so all the trig relationships hold. What about this? Okay, there's one little caveat here. You have to be very careful. When we get into calculate, these are called indefinite integrals because you don't have numbers to calculate C.
Okay.
When we get to definite integrals, they might have negatives here. Can natural log have a negative in it? No, so we have to make sure that we take care of that with the absolute value. Because that's just a little tweak.
Okay.
Okay? It's not on drugs, it's just a little tweak.
It's bigger. Like my car.
Did you hear Miss Karen's story yesterday about going to Vegas?
Yeah.
Oh, my car broke down and then they were like, who used you? Because
It's like I hear good people.
You know, that was
behind us. Oh God.
imagine introducing yourself.
Here's your favorite.
She's disorganized.
How do you find this stuff out? Who made this up?
Like
That's
Evan
what I
said,
said.
though,
It's
so
The
do
guy walked in a room.
just thought this
All
up.
the stuff.
What is?
Smart stuff.
What's going to be crazy is what these actually calculate.
Well, isn't easy?
Okay, so
That's
what's-
just easy.
Oh, that's hard. Don't forget your plus C. Your basic antiderivatives.
Area under a
Yeah, what does this calculate?
area under a curve.
Remember that?
Right.
from
Look at
last year.
Yosemite
A lot of you
Sam,
might
right
remember that
next
from
to you.
last year.
I don't remember that.
That's calculus. We have to do that.
So derivatives calculate slope.
Oh, we do have to do that.
Antiderivatives or integrals calculate area under a curve. Kellen.
So if it was X squared
After
minus
this
one.
class,
Okay.
we'll be able to
One more.
I'm just having trouble writing it
volume of your guys.
Okay, don't forget to close your integrals with the X.
Writing a lot of S's.
So this would be, what's the antiderivative of x squared?
It's cubed over
Okay, x cubed over 3 minus, what's the antiderivative of 1? X.
Oh,
Again, you're literally following derivative rules, you're just working your way back. So,
this is,
now that you we're up in arms, is it that difficult?
no, it's too easy.
That means it's just going to get harder.
For now.
It's for now, because there's still 2 more days.
Don't we spend the whole second semester on work on that?
No, third quarter,
Yeah, I think I heard 4.
working with integrals, and most of it is applying them.
Great. That's where it gets hard.
There are
Calculate the volume in a
very
record.
few, there are a lot fewer. Stop here. Yeah, I'm gonna give you some work here. It's not in a classroom yet, so don't trust that it's gonna be there.
Is it due tomorrow or due Thursday?
Zach Seiler to the office, Edison Arbarca, Edisina Jimenez, Kate Paulson,
Let's make
Angela
it
Parrish, Kayla Ryder.
do you want to
Somebody else, please come to the office.
do Thursday?
Okay.
Mr. Arthur?
Keeping in mind that you have study time for your finals. What?
Why did it say 135-1?
Because